Hello, welcome to another exciting episode of Experimental Physics. Today our topic is on electricity, and we are going to look at the resistivity of a wire. We are going to look at how to determine the resistivity of some wires, specifically Constantan and Nichrome wires. So we are going to use some apparatus, and on my left here is a power supply. We have a key. We have our ammeter that is used to measure the current. Our voltmeter here will help us measure the potential difference across, and some connecting wires. These are the two wires that we are going to use. One is Constantan wire, and the other one is the Nichrome wire. So that is that. So let's get to it. So to do that, we are going to measure the length of the wires and also their corresponding potential differences. According to Ohm's law, it says that when the current is passing through a metallic conductor, the potential difference is directly proportional to the current, provided temperature and other physical parameters remain constant. And we also know that based on the resistivity or the resistance of a wire, which is given by the resistivity times the length over the cross-sectional area, there is a relationship between the resistance of a wire and the length. And as the length increases, the resistance increases, which in effect increase the potential difference. So we can measure the resistance of a wire by measuring the length and also the potential difference. That is that. So let's do our connection. So we have our ammeter here. We connect our ammeter in series to our power supply here. So we connect our ammeter to our power supply. Then we connect our switch on the other side of our power supply. And the switch is going to help us open and close the key once we are picking the reading. So from the key, we connect the other side of the key to one end of our wire. So this is the one end of the wire. Then from the other side of our ammeter here, we connect another wire. Connect another wire from the other side of the ammeter to the other end of the wire. So from the power supply to our switch, from the switch to one end of the wire, and the other end of the power supply to our ammeter, and from our ammeter to the other end of the wire. Now we need to connect the potential, our voltmeter, and our voltmeter is connected in parallel. So what we do is that we connect one end of our voltmeter to one end of the wire, but we are using Nichrome wire, after which we will replace with a Constantan wire. So this is our voltmeter. Then we use a jockey. So we connect a jockey to one end of our voltmeter, and the other end of the jockey will be used to measure the potential difference of the wire at different lengths. And we are going to use a length of 10 centimeters, 20 centimeters, 30 centimeters, 2 to 100 centimeters. So that is how we are going to do our experiment. All right. So when you take the voltmeter, we adjust it. This is a multimeter, and it can be used to measure the current, voltage, resistance, capacitance, and so we call it a multimeter. It can be used to do all these things. So we turn our multimeter to voltage, okay? Because this one is used to measure the potential difference. Then we turn this one to ampere, because we are going to use to measure the current flowing through the circuit. So now our circuit is complete. We can turn on our power supply to measure the potential difference across the length of the wire. So now our circuit is complete, so we can close our key to record our values. All right. Okay. Now for you to know that what we are doing is correct, the current from the power supply must be approximately the same as the current that our ammeter is reading. So you can see that the current here is 0.33 ampere, and that one that the ammeter or the one the ammeter is recording is 0.34, which is closely approximately the same. All right. So we are going to take a length of 10 centimeters. Then, with the help of our jockey, we will touch the tip of the jockey with the wires, okay, or the wire. Then after that, we will record the potential difference that will be measured by our voltmeter. Okay, so at a length of 10 centimeters, we are recording a voltage of 0.858 volts, a voltage of 0.85 volts. Then we move to 20 centimeters. So at 20 centimeters, we are getting 1.108 volts. At 30 centimeters, we are getting 1.351 volts. At 40 centimeters, we are getting 1.604. At 50 centimeters, we are getting 1.852. At 60 centimeters, we are recording a voltage of 2.098. Then at 70 centimeters, a voltage of 2.350. At 80 centimeters, we have 2.95. Sorry, at 80 centimeters, we are recording 2.595. 2.595 rather. Then 90 centimeters is giving us 2.840 volts. 2.840 volts. Then 100 centimeters is giving us 3.125. 3.125. So that is how we record the potential difference across the length of our Nichrome wire. And we are done. After that, we have a micrometer screw gauge, which we are going to use to measure the thickness of the wire. We know that the area of a wire is given by pi d squared on 4. So if you're able to measure the thickness, that is the diameter, we can calculate the area of the wire that we are using. So with the help of the micrometer screw gauge, we are going to use it to measure the thickness of the wire. What do? We just have to take 5 or 4 different lengths across the wire, then we measure the thickness. So we take this end, for instance, then we measure the thickness using our micrometer screw gauge. Our micrometer screw gauge. Okay. All right. So we are recording 0. Sorry. The micrometer screw gauge measured in millimeters. So that is the unit of the instrument that we are using. That is the unit of the instrument we are using. Okay. So we are recording 0.25 millimeters. 0.25 millimeters. 0.25 millimeters. Okay, that is one end. We can take multiple lengths of the wire to find the average of the thickness. Okay.
Okay, so this one is giving us 0.2 millimeters. 0.2 millimeters. Let's take another one here. This one is giving us 0.27 millimeters. 0.27 millimeters. So we add these three values, then we find the average by dividing by 3. So we had 0.25 plus 0.20, then 0.27 divided by what? 3. And that will give us the average of the thickness of what? Of the wire. So we change this value from millimeters into meters, and we will use it to calculate the area or the cross-sectional area of the wire that we are using, which will help us determine the resistivity of the Nichrome wire. We have length in centimeters and their corresponding potential difference, that is voltage in volts. So for 10 centimeters, so for 10.0 centimeters, we recorded 0.858 volts. Then for 20 centimeters, we recorded a potential difference of 1.108 volts. Then for 30 centimeters, we recorded a potential difference of 1.135. Then for 40, we had 1.604. For 50, we had 1.852. For 60, 2.092. For 70, 2.350. For 80, 2.595. For 90, 2.840. Then for 100, we had 3.125 volts. So these are the values recorded for the voltage or the potential difference across the length of the wire. And we can see that from the data, as the length is increasing, the voltage also increases. The voltage also increases. So by using Ohm's law, that V is equal to IR, we also know that the resistance of a wire is given by rho L on A, where rho is the resistivity of the wire, rho is the resistivity of the wire, L is the length of the wire that we use, and A is the cross-sectional area. So by substituting R into the Ohm's law equation, we know that V will be equal to the current times, instead of the resistance, we will get rho L on A. So from here, we had voltage and we recorded the length. So we can plot a graph of voltage against the length. That is voltage on the vertical against length on the horizontal. And from there, the gradients that we will record will be equivalent to the gradient or the coefficient of the equation. So the gradient from our plot will be equal to the gradient of this equation, which is the current times resistivity divided by the cross-sectional area. So we can make the resistivity the subject here, which the resistivity will be equal to the gradient M times the cross-sectional area A divided by I. And from there, we can find the resistivity of the Nichrome wire. So this is how we are going to use our graph of voltage against length to determine the resistivity of the Nichrome wire that we use, from which we will replace the wire with a Constantan and also determine its resistivity. Thank you.